Let's continue looking at firewalls and um, their relationship to our perimeter defense. A few definitions. What is a firewall? And as I was writing this, I became aware that in recent years um, we have more and more firewalls that run on individual computers just to protect that one particular computer. I think it was Service Pack 2 with XP that introduced the firewall to the XP operating system. Microsoft servers operating systems have built-in firewalls. Now, Linux and Unix have always, or at least for many, many years, have had the ability to run a firewall on a box just for the express purpose of protecting that box. So I was reminded that there's more to this whole concept of a firewall than what I was thinking at the time. So I'm going to qualify my definitions here with the word traditionally. So a firewall is traditionally software running on dedicated hardware. And if you have this situation, this is often called an appliance. Now this is a fairly new word, but it is used extensively. Or it's software running on a regular computer that's dedicated just to running the firewall. That's what its job is, or maybe one of its main jobs. So, moving on, a firewall traditionally, again, we're not talking about I hesitate to use the word personal firewall, although that's what some products call the type of firewall that protects just a single machine. I guess we do need a better term there. But anyway, a traditional firewall typically has two or more network interfaces. And my third bullet here was what I've already explained, that recently firewalls have been added to servers and workstations. And again, the point here is these firewalls are to protect that particular computer. And they're good things. We might get around to talking about those specifically. So, no matter what type of firewall you're talking about, what does a firewall do? Well, the firewall looks at every packet and evaluates it against a list of rules called a rule base. This is where the configuration comes in. Someone has to develop the list of rules and enter them into the firewall. And typically what happens here is the first rule that matches a particular packet is applied, and typically the rules are evaluated from the top down. So this has implications in the ordering of your firewall rules, and we're gonna do some experimentation with this, and there'll probably an assignment on this. The actions that can be applied to a packet are to forward it to another interface, and sometimes it's really referred to as forward. Other manufacturers refer to it as accepting the packet. So you run across different terminology. It's usually obvious what the developer of the firewall meant for a particular word that they're using. And the alternative is to not forward it. Uh, and again, we often refer to this as dropping the packet. And a rule that allows a packet to pass through is said to open a hole in the firewall. You want to minimize the holes in your firewall. The more holes, the less protection you have. Now, what can you write rules on? What situations? And this may not be a complete list. That's the reason I put etc. down here. And the reason I say this is we're adding more and more functionality to firewall applications. So it's there's probably things out there that I haven't seen yet. Anyway, you can write rules on source and or destination IP numbers, and either a single IP number, or you can do a whole range, a whole network. And there's reasons why you should, and we'll get into this later. There are whole blocks of addresses, whole networks that you should block, both going and coming actually. And I'll talk to you about those. You can also write your rules on source or destination TCP or UDP ports, protocols. You can block or allow by ICMP code and type, etc. So there's a number of things that you can I would refer to all of these as qualifiers that you can use to write your rules on or about, if you prefer this. Here's a firewall functional diagram, and for some reason we have a little artifact here. This little part right there doesn't really belong. So we have a network interface. We have two network interfaces here. If we simply assume this is the public side, and I don't know why I drew a B. I'm evaluating a new tablet here, so sometimes it does things I'm not really expecting. Anyway, I drew this diagram in Visio, so I guess I have an artifact here. That little vertical line there doesn't belong. So if this is the public side, we can have packets going in. We can have packets coming back out. You can draw that any way you want to. We'll assume this is the private side. Again, we can have packets going each way. If our firewall had more than one interface, it would be over here somewhere, and we could there are obviously limits to how many interfaces you can have, but I've seen advertisements for 5 or 6 different interfaces if you have a complicated network. So let's look at basically how this would work. If you have a packet coming in from the public interface, it's going to be passed into the engine. Then every rule in order in the rule base is going to be used to evaluate the packet. And if it matches one of the rules, it's going to be sent on through to one of these private interfaces. let's assume here that matches and accept, because we could have a rule that says deny. So we'll put deny here. And the packet's just dropped. It simply goes the way of all ones and zeros that are no longer needed. I'll just draw that on there to kind of give you some indication of what happens to it. And I'm showing a packet coming in from the outside. You can and actually should filter a certain amount of things going out of your network. Although we're typically much more liberal as to what we allow going out from our network to the internet. There are still some things it's a good idea to filter, and again we'll talk about those later. So where are you going to put your firewall? Now remember, this is your traditional firewall. There's several places between your network and any connection to the internet is certainly where you'd want to put one. You could have a firewall between the internet and your public web servers, FTP servers, email servers, and DNS servers. Probably. And if necessary, if it suits the your own purposes or your internal security policies, you could put firewalls between segments of your own network to control the flow of packets into and out of sensitive parts of your network. For example, maybe your company does a lot of research and development on new products. You might want to put your the file servers that have the newly or the products under development. You might want to put a firewall between that and the rest of the people in your company that don't necessarily work with the new products, to cut down on instances of industrial espionage and your own workers stealing your secrets. And we haven't really talked about that, but it is a big deal. Here we have a drawing. This is a fairly typical arrangement, both from a company standpoint and placement of your firewall. And here is our firewall. It has 3 interfaces. So we have one for the what we often refer to as the public interface, and this is your private network. And then often we refer to this as the demilitarized zone. I really don't like that word or term. I prefer to call it the service network. Other things we have on here is this is a router. And not only are we going to use it as a router, we're also using it to do some basic packet filtering. Now, if you're thinking that that's what the firewall does, you're correct. There are some things that you can let your router do that will take some of the load off of your firewall. For example, I mentioned earlier that there are entire networks that you want to block. This is something that routers are really good at, blocking entire networks. So we're going to let our router do that, and then our firewall won't have to worry about um, blocking those. And this will improve the performance of your firewall. It'll hopefully keep it from being overwhelmed by the number of packets, among other things. So here's the internet, of course, to give you some idea where we're going to put our router and our firewall. This, the lightning bolt here, is your connection to your internet service provider. We also refer to these as WAN links, wide area network links. Now let's go out here and look in the service network and see what we have here. And you need to add a S here. There needs to be 2 DNS servers here that are authoritative for your the fully qualified domain name of your web server. Now, depending on the size of your company, you might want to consider just farming this out. For example, there are many companies that will do web hosting for you. Now, here's the things I think you need to think about it for your web server or your web hosting. Number one is, how big is your company? And number two, number one, let me elaborate on number one. The smaller the company, probably the more sense it makes to outsource the hosting. But this leads us into number two. You have to consider what you're going to use your web server for. If it's information only, certainly it's not a big deal to have another web hosting company host your web server. And also the DNS, the 2 DNS servers that's required when you register your internet domain name. And if you're thinking this has nothing to do with firewalls, yeah, probably. But I'm going to talk about this while I'm thinking about it. Now, if you're going to use a web server to do electronic commerce, again, there are ways you can, or companies that provide this particular type of service, shopping carts, etc. So, even if you're a small company, you can probably, successfully farm all this out. And then you won't have to worry about maintaining and securing the servers, etc. at your site. So there's some advantages to this. If you're going to use your web server to extensively access a database, that's probably, well, it doesn't have to be, but often is running on a separate database server, it gets more problematic to do that at somebody else's site. So that may be some reason you want to do it, host your own web server, and then internally you can have it connect to an internal database server. So we'll look at that situation here another slide or two. Anyway, the same thing actually goes for your email. You can either do it yourself, or you can farm it out. You can write a check every quarter, and you often give up some functionality, but you don't have to worry about certain things that you would if you were maintaining it yourself. Anyway, If you decide to host all these yourself, a really good option is to put these on a separate interface off of your firewall. And by putting these machines on a separate interface, you can write different rules to control traffic into and out of that particular um, network, the demilitarized zone, or the um, what I prefer to call it is the service network. So um, to review here, we have to have a router, so we're going to use it to also do some basic packet filtering. Since we have a DMZ and a private network, there's a really good argument here for a firewall, and this would be the place most people would put it, I think. Sometimes you see drawings where the firewall is in front of the router, between the router and the internet, and I don't agree with that. I think you should put your router out front and let it do some of the basic packet filtering for you. So the firewall we have here has three interfaces. One's public, one hooks to our private network, and one to the service network. Now, since we have three interfaces, we can write rules concerning packets into and out of any of the interfaces, and actually all the interfaces. This gives us more control over our filtering. Slightly more complicated network diagram here, and I've kind of alluded to some of the issues here. We still have our packet filtering router, we still have the internet, still have our firewall with three interfaces. Out here in our service network, we have our two DNS servers, and these are for our internet domain. And I can't remember if I mentioned the fact that if you register an internet domain, you have to give the registrar the IP address of two DNS servers that are authoritative for the domain that you're registering. You have to do this. So here's our two DNS servers for our internet domain. And the only thing these DNS servers are going to, these will answer, let's call this external. External DNS answers queries for again, I'm having trouble with my new tablet. Let me fix that. It seems like whenever you get near the edges of the tablet, it doesn't work as well. Answers queries. So I'll try to concentrate here. For the web, email, FTP. The point is, your external DNS servers are only there and only have records to support queries for your email servers, your web servers, your FTP servers, if you're using any, etc. They're truly just public. Now, since I refer to this as a Microsoft network, internally we're going to have um, an Active Directory domain, and we're going to need at least 2 domain controllers. And if you were using Active Directory integrated DNS, DNS will be running on our domain controllers. Now this DNS is here to support Active Directory, and it also handles internal queries for external resources. So this is what we refer to as split DNS. And if you're sitting there wondering why are we talking about this and while we're talking about firewalls, this is more of a security issue. So this is a security class. The DNS, your DNS servers are probably the highest value target in your organization, with the possible exception if you've got a database server sitting there with 100,000 credit card numbers and personal information to go with the credit card numbers. That's a pretty high value target too, but most people will tell you that you have to pay particular attention to your DNS servers. If somebody compromises those, they can change the records inside, they can reroute queries, they can do a lot of damage. So this particular setup here, yes, we have 4 machines running DNS, minimum of 4, and that's a lot of computers. But on the other hand, from a security standpoint, we've split our DNS. The one that the DNS that supports Active Directory is totally separate from the external DNS servers. And the idea here is, again, you want to protect your internal resources, and as far as the external DNS servers, you've got to have them out there. Now, these are the ones you want to monitor carefully, make sure that you're patched religiously. So you're going to try to minimize your exposure while doing the things that you have to do. Anyway, I just wanted to point that out. There's a couple of other little wrinkles here that we haven't talked about before. Syslog server. Syslog is started out life as a Unix type service, and I'm trying to think. It's port 514. I was trying to remember whether it usually is runs over TCP or it's UDP. Okay, well, we can look that up. What a syslog server does, and there's a reason it's a good idea to have a central syslog server. It allows you to consolidate all your logs in one place, and it makes it easier to look at if you have some sort of issue. It's easier to correlate the logs because they're all in one place. From a security standpoint, well, from the firewall, we're going to set up logging on our router, and we're going to have to open up a hole to the syslog server, and again logging on the firewall, and put it over here on the syslog server too. So those are things we're going to have to make sure we have rules for. So let's see, we've talked about the service network. We've talked about the internal network. In this case, I've introduced this whole concept of split DNS, where you have external DNS to just simply handle external issues, and then you have internal DNS servers to handle the internal needs of your network. And talked about syslog briefly. Now, we're going to come back and we're going to look at some of these networks in more detail after we've done some firewall configuration. So this is the same drawing that I had previously. And the reason I put it in twice, I wanted to kind of introduce you to some of the concepts. For example, if someone sends some mail, it's going to go through the router, and we're going to have to open up a hole in our firewall here for email. Now, let's look at briefly what that's going to look like. For email, from any IP, any TCP port. Let me write this down and I'll explain it to you. To IP of our email server port, that's a T, TCP 25. So I wrote this out in English. You'll have to change the syntax of this for the particular firewall that you're going to be configuring. But let's look at this. The way email works, an email server, when mail is getting moved from server to server, there's going to be it's going to go over port 25, but the initiating connection, this is the from part, this is the source. We don't know what IP number the sending mail server is using, and since the source port is typically a higher numbered port chosen at random, we don't know what the source TCP port is. We do know the IP number of our email server, and we know that the traffic's going to the destination. This is the destination side. The destination is going to be TCP port 25. This is the port of the simple mail transfer protocol. So that would be an example of a rule for email. And we could write a similar one for the web server or our external DNS servers. Let's see. Okay. Let's assume here that we want to write a rule to access our database server from our service network. Let's see what it would look like. So the source side is going to be from the IP of our web server again, any TCP port could be used to as the source port, to address to IP of our DB server, TCP port. This is going to depend on which database software you're using. Just trying to think. Microsoft SQL Server, for example, is, I want to say TCP port 1433 and 1434, but we'll have to look that up. Let's put a big asterisk here. That should have been a D. What I'm going to write here is this, what goes here depends on which database server we're using. Did it again. Just wipe that. Depends on database software being used. I'll erase that. You write that. So my point here is, in some cases, when we're writing rules, we know very little about the source. For the example of email, it could be any IP number or any TCP port number. And in other cases, we know a lot about where, or in this case, we know, well, we just still don't know everything. We know a lot about the connection from the web server on our service network. And this was the rule we were writing, the second rule here. So in some cases we know quite a bit about the initiating connection, in some cases we know very, very little. But both of these are examples of rules that will open up a hole in our firewall and allow traffic from one interface to another. And of course, there's some other things we want to think about here. You know, the big thing is, where in the order of things do you put these rules? If you know, for example, that you've been getting a lot of spam from a particular a mail server at a particular IP address, you could write a rule to block that IP address, but you'd want to put it before this rule. Otherwise, this rule is going to be triggered first, and you're still going to get your spam. So rule order is important. We'll talk more about that later. So on this diagram, I give you an example of a couple of rules, firewall rules, just written out in English. Now you'll have to translate this into the syntax of your particular firewall. And the firewall we're going to play with, you actually have a web-based management interface, and that's increasingly common. So in a lot of cases you'll write your rules out in something like what I've done here, and then you'll go into the management interface and do some clicking and enter your rules into your firewall. And then of course you want to test them. And I've been thinking about some ways to test our rules. So we'll get to that, I hope. So I'm thinking that's all I need to really talk about in this particular video.